Atmosphere. This is one of the first spheres from the Earth system. Yes, we learned that there were 4 systems in the Earth. The first one was the atmosphere. The atmosphere is a thin envelope of gas that surrounds the planet. This envelope acts like a coat for Earth, as you wear a coat to keep warm, yes? Similarly, the atmosphere protects the planet, protects our Earth from the harmful solar radiations, and keep the Earth's temperature within a range that allows life to exist. The protection our atmosphere provides is just right, not too heavy, not too cold. We saw that the Earth system involves flow of matter with the help of energy through different components, yes? Now let's see what are all the matters present in the atmosphere. It's composed of nitrogen, oxygen, argon, carbon dioxide, water vapor, and water droplets. Nitrogen makes up about 78% of the air we breathe. Oxygen is essentially for animal life and makes up about 21% of the atmosphere's gases. The remaining 1% of the gas in our atmosphere consists of trace or very small amount of gases like argon, carbon dioxide, methane, ozone, etc. Though these gases are far less abundant, they help insulate the Earth by trapping solar energy before it escapes into Earth. The atmosphere also contains water vapor and water droplets. Water vapor is basically the gaseous form of water, yes? The amount of water vapor in the atmosphere varies from nearly 0% in the driest deserts to as high as 4% in the most humid tropics. Water vapor cannot be seen, but when it condenses into tiny droplets of liquid water or frozen ice, it forms the cloud we see in the sky. Now let's see the different layers of the atmosphere. As we have learned that the density in the atmosphere decreases the further up you travel from the surface. In fact, those changes creates distinct layers around the Earth. There are 5 layers that we know of. The stratosphere, the first one would be the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So the lowest layer is the troposphere. This is where all the weather occurs. Here there is almost 99% of water vapor in the atmosphere. When all the layers of the Earth put together, most water vapor is found in the troposphere. It extends from about 10 to 20 kilometers. Next, coming on to the stratosphere, which is the second layer above the troposphere. This is where the ozone is found. The ozone absorbs all the harmful UV rays, yes? And the airplanes also fly in this layer because there are less cloud. So the airplanes to fly, there has to be less cloud, so there is less turbulence. And this layer extends from about 20 to 50 kilometers. The next layer is the mesosphere. It extends about 85 kilometers. Mostly the meteors, are burnt in this layer. The coldest temperature that this layer can have is about minus 90 degrees centigrade or minus 130 degree Fahrenheit. The next layer is the thermosphere. It extends anywhere between 500 to 1000 kilometers above ground. The northern lights and the southern lights occur in this layer. Next is the exosphere. This is the layer where the satellites orbit. It's the uppermost region of the Earth's atmosphere as it gradually fades into the vacuum of the space. The air in the exosphere is extremely thin. In many ways, it's almost the same as the airless void of the outer space. This can extend from about 19,000 kilometers from the ground. Moving on to the next slide. We saw all these, yes, the matter in the atmosphere: nitrogen, oxygen, argon, carbon dioxide, water vapor, and water droplets. How is nitrogen obtained? It's obtained by a process called nitrification. Where do we get oxygen from? Through photosynthesis. The plant breathes out oxygen. Argon is found by the decay of potassium. Carbon dioxide is through respiration. We breathe out carbon dioxide. Now let's do a small experiment to see how the different layers of Earth do not mix with each other. Here I have taken a transparent glass and first I'm pouring in sand, which would be the troposphere. Next we'll use something a little more dense, like a corn syrup, which would be the stratosphere. Notice how they don't mix, because the sand is denser than the corn syrup, obviously. For the next layer, that's the mesosphere, I'm using dishwashing liquid. If you can see in here that the dishwashing liquid does not mix with the corn syrup. That's because the corn syrup is more dense than the dishwashing liquid. Now I'm pouring water. I basically mixed some food color with the water. And if you notice here again, the dishwashing liquid does not mix with the water. That would be the mesosphere. The thermosphere. And next I'm using oil. Any oil should be fine. You guys can do this experiment at home to see how the layers, they do not mix with each other. That's because the density of each liquid is different. It's the same concept with the atmosphere. Each layer of the atmosphere has different density. That's why they don't mix with each other. So now that we saw the video, let's see what all we observed. Okay, what did you observe as you poured each liquid into the beaker? Are there perfect lines between each liquid? Can you match each liquid to a layer of the atmosphere? Now that we saw the different matters in the atmosphere, now let's see how the matter flows in this system, that's the atmosphere. Let's start with air pressure. The atmosphere is composed of tiny molecules of gases, water vapors, and particles. Each molecule exerts a small amount of force. Imagine a column of air above you that extends all the way into the space. This column of air exerts a force on you called air pressure. Earth's gravity pulls the molecules in the atmosphere towards the surface. The weight of the molecule presses down on the molecules below them. As a result, the molecules closest to the surface of the earth are pressed the most. That's why they are arranged more closely together. As you move up through the atmosphere, the density or the amount of particles decreases. The molecules are more and more spread out in here. The distance above sea level is called altitude. The higher the altitude, the lower the air pressure, because there is less air pressing down on each particle. Air pressure is measured by a barometer. So that's why you'll see a high pressure near the surface of the earth and low pressure as you move away from the surface of the earth. See, it's densely packed in here, so that's why high pressure. Next, moving on to air mass. Air mass is a characteristic of air, named using the temperature and moisture content in it. For example, warm moist, warm dry, cold moist, cold dry. When the air mass move along with wind, they carry their weather conditions like heat or cold or dry or moist that we saw from one region to another region. So let's see how to name an air mass. Two things that you should know is an air mass will have two names. One from this, you'll select one from this, and the second you'll select it from in here. So maritime means when the air mass is over the ocean, we will name it as maritime. And if the air mass is on the land, then you'll name it as continental. And if the air mass is near the equator, you'll name it as tropical. And if the air mass is away from the equator, that's over here, you'll name it as polar. Where does the equator lie? The equator lies in the center of the earth, yes? So this part would be the hottest. As you move away from the equator, it's gonna be cold. Let's do a small exercise in here. So let's name how the air mass would be in this region. This is over the ocean, yes? So you'll have to select maritime. And it's far from the equator. So you'll select polar. So it would be maritime polar. So let's check if that's right. Yes, it's maritime because it's in the ocean and polar because it's near the poles. Another example, How would the air mass be named if it's in here? So we are noticing that the air mass is over the ocean, yes? So that would be a maritime, and it's close to the equator, so it's gonna be hot. So it would be maritime tropical. Now can you guess what would the name of the air mass would be if it's in here? It would be continental polar, because it's over the land, so continental, and it's near to the pole, so polar. One more example. Can you name what the air mass would be if it's in here? It would be continental tropical, because it's on the land, so it's continental, and tropical because it's near the equator. Now that we have seen about air mass, let's move on to the next slide. That's air fronts. Wind blows away from high pressure to low pressure, yes? When doing so, air masses also get moved from areas of high air pressure to areas of low air pressure. When the two different air mass comes in contact, they don't mix. They push against each other, forming a boundary called a front. There are different kinds of fronts. Let's start with the warm front. Warm front produces clouds when the warm air gets replaced by cold air by sliding above it. Different cloud types can be formed in this front. Example: stratus, altostratus, cumulus, altocumulus, and cirrus. This air front brings light rain followed by clear sky and warm weather. Mostly the warm air front is going to have a clear sky and warm weather. But whereas in the cold front, it occurs when the heavy cold air displaces the light warm air above. The cloud that forms in here are the cumulus clouds. They often grow into cumulonimbus clouds, and they bring thunderstorm, hail, snow, and tornadoes. So for the cold front, it's going to be thunderstorm, snow, and tornadoes. So that's what. Let me explain again. A warm front is when an approaching warm air gets pushed up because there is cold air. That's a warm front. A cold front would be when an approaching cold air gets pushed down. That would be a cold front. What's a stationary front? Stationary front forms when a cold air and a warm air stop moving and they slide basically. This happens when the two masses of air are pushing against each other, but neither is powerful enough to move the other. So that's a stationary front. An occluded front forms when warm air gets caught between two cold air masses. The warm air rises as the cold air mass push and meet in the middle. The temperature drops as the warm air mass is occluded or cut off from the ground and pushed upwards. Such front can bring strong winds and heavy precipitations. All these matter, that's the air fronts, the air mass, and air pressure causes different weathers and climate. Weather means short-term state of the atmosphere. Climate is long-term pattern of the weather. Weather, you can give examples like rainy, sunny, windy, or cloudy, or stormy. That weather can change in minutes and hours, yes, but for the climate, it's an average weather over many years in one specific place. So weathers can be stormy, cloudy, sunny, rainy, and windy. For the climate, you'll have to name it as tropical, dry, temperate, continental, and polar. Now let's see how the energy helps the matter flow in the atmosphere. The sun is what provides the energy for the atmosphere. Yes? This energy is in the form of heat. Heat energy from the sun gets transferred in three ways. These rays causes transfer of thermal energy by three ways: radiation, conduction, and convection. Radiation, heat transfer through waves from the sun to the earth. What's conduction? Energy from the sun warms up the earth's atmosphere, yes, as it reaches its surface by radiation. Some of that energy that hits the earth's surface is absorbed by the land and the water, and some of it is reflected back into the space, yes. And now this warm land and the water that touches the air above it It's gonna heat up the air, yes? That's how convection occurs in the earth. What is convection? In convection, the air near ground heats up the air near the sky, thereby redistributing the heat. How does that occur? Earth has got heated up because of convection. The heat is transferred upwards and outwards away from its heat source, and the cooler air is brought in to replace the rising air. So this is a cycle that's happening in here. That is called convection. Atmosphere traps the sun's heat. And the gases that help with this process are carbon dioxide, nitrogen dioxide, and ozone. The greenhouse effect is one of the things that makes Earth a comfortable place to live. So you see that there is solar radiation coming in here, and when it's going to escape, these gases like carbon dioxide, nitrogen dioxide, ozone, and methane, they're going to trap that heat and they basically reflect back to the Earth. Greenhouse effect is good as such, but when excess of it happens, that's when there is global warming. These greenhouse gases are good when they are in a limited value, but nowadays, because of pollution, because of people cutting lots of trees, these gases are becoming more and more, so they are trapping in more and more of heat. So that's why there's more global warming happening. Next, let's see how the wind is formed. Wind belts are formed due to unequal heating of the earth and the earth's rotation. How does the earth get unequally heated? Now let's imagine that there is sun in here, and there's going to be heat that comes to the center the most. That's where the equator is. That's where the sun rays are more concentrated. As you move far away from the equator, the rays of the sun are going to get distributed a lot. It covers larger area. So the sun rays in these areas, like the poles, are going to be less intense. The uneven heating of the earth creates a temperature imbalance. Yes, there's temperature imbalance in all these spots. There's more temperature in here and less temperature in here. The moving warm air from the equatorial region goes to the cold polar regions by the process called convection. This simplified convection currents begins when hot air rises at the equator and cold air sinks at the poles, thus creating our wind.